Hi folks, welcome. So this talk will assume you're a bit familiar at least with scikit-learn. If not, don't worry, at least near the end the takeaway should be clear enough for anyone. So I'm Christian and I love scikit-learn. Why? If you have some data, scikit-learn makes it really easy to get a first model trained quickly. And so if the problem is a bit more complicated, then maybe you'll need to do some feature engineering on that. So I especially love scikit-learn's pipeline. With a little bit more work, I mean, the big thing, most of the code is taken by a big dictionary that says how to explore the hyperparameters. So with a bit more work, you can have like multiple transformer steps. You can train your model in a proper way. That would actually be a good way to get an out-of-sample estimate of your model's performance in production. And it still fits on a screen. It's amazing. But let's say your data doesn't look like a big array of number, but more like this. So you have dates, you have categorical values, correlations between columns and rows. So for that, Pandas is amazing if you use Pandas. And so the question is, can we get these two to play together? So can I take my model and just replace the line at the top with load complicated retail dataset, and will it work? Well, not sure. Like so, Pandas DataFrame and numpy array aren't quite the same beast. They're pretty different actually. So one way to make this work is to go back. So like I'll delete the pipeline, delete the Kfold validation, and this almost works now. If I convert things to categorical values, then we have a model, but we've lost. It's not surprising that this works. I mean, the Pandas stuff is above the line, the scikit-learn stuff is below the line, and you're keeping them really separated. And then you can add whatever you want at the top and at the bottom for their respective libraries, and that does work, and that's what we used to do. But you've lost a bunch of the nice features of scikit-learn. So you've lost pipelines, you've lost the ability to do splits easily. So the question is, can we do better? And the answer is yes. Used not to be the case, though. So if you're like me and you've been trying to get these two to work together for a little while, then you may have gone through, like, tried it out in the past and figured out, oh, this really wonky, this doesn't work. And this talk is basically telling you it's time to look again. And so we'll look at the two components. First, the splits and the model selection. So the documentation of scikit-learn is really good, but for these things you kind of have to know where to look to find the fact that it's supported. It's not very well advertised, sadly, at least not currently. And so this is the documentation for the train test split function as an example. And you have to kind of read all the way at the bottom of the slide to see allowed inputs are like numpy arrays, etc., or Pandas DataFrame. And actually, they would probably also not even show up in autocomplete. So if you're using an IDE or Jupyter Notebook, if you do the autocomplete, usually it shows like sequence of indexable with same length. So yeah, DataFrame is indexable, but not in the same way as a numpy array. Will it work? So I looked into the source code to see exactly what was happening. So this is actually the definition of indexable, and you can see in the middle that if you have, this is called at the beginning of all the model selection functions to convert things that are not indexable, and if you see in the middle, it supports DataFrame, it looks for iloc, and if it sees that, it just passes it through. And this is the other half, so if you have iloc, you will use it to get the indices to subset your training set or data set properly. So this works. Pipelines. This is the documentation for the fit method of the pipeline class, and you read it, and you see like the thing that worried me when I read this. You see like parameters x and y must be iterable, that the doc says, and like, is this going to work again? Because if you iterate on a numpy array and a Pandas DataFrame, it won't give the same kind of results. One will return rows, the other columns. So I looked into the source again, and I pulled out this is basically the transform helper method for the pipeline class, but all the others are similar. Basically, what's happening under the hood is just a for loop on all the pipeline steps, and the output of a step is fed into the input of the next step. So anything that works like that will actually work. And so there's no magic also for writing Pandas pipeline steps, you just expect to get a DataFrame and input, and you learn things in your fit method, and then you apply them repeatedly in your transfer method. So if we put that all together, so as a combined example, yeah, we're back pretty much where we started, and actually this now, well, almost works. There's a thing in the middle we still need to take care of, but we can use time series split, which is a new splitter in 0.18, because our dataset has a date, so you don't want to pass dates from the future into the past. So it expects your array to be sorted in order of increasing time, so you do that at the top. And the only missing thing is something to convert your data frame into a bunch of numbers again, but in a train test perspective. So you want to do it once when you train, and then redo exactly the same thing when you test. So there are a couple options, picking daskml actually for this. And so if you pop these two classes here, it'll do the conversion for you in the proper way. And this actually works, and you get all the benefits now. So our experience at JDA Labs using this, we've been using this for a couple years. It's worked out really nicely. We started using it in the beginning mostly for the pipelines because that's a really nice way to structure things and try many kinds of different transformation steps. We couldn't use splitter in the past because we have more complicated data with time relationships, and that wasn't well supported before 0.18, but actually now with the new splitter interface, we could start using it. And we wrote our own code to do the transformation from Pandas DataFrame, the dummy encoding, but don't do that. There's no reason to do that anymore. There are a couple of libraries that are starting to pop up for that. And so in summary, use at least scikit-learn 0.16.1, preferably 0.18. For splits, anything pandas-like will work. For pipelines, in theory, as long as each step accepts the output of the next, you're fine. In practice, you'll probably want to put all your pandas transform at the beginning, convert into all numerical numpy array, and then all numerical steps after that, PC, etc., and then the actual model. And writing a pandas-based transform is pretty much the same as writing a numpy one, except for the input. So I won't go over the next few slides, but they're here for reference. So if you want to dig further, there's some of the relevant changelog entries for this, some of the relevant commits, some related projects, like daskml is really nice and is supporting, if you need to parallelize things, have a look at it, but also it supports explicitly Pandas DataFrame, so you can use it if you're ready to handle the dependencies. Other useful projects, still missing is a library of transforms for Pandas DataFrame, so you'll tend to write a couple small helper classes. Maybe they'll come one day. Although there's in 0.17, there's a function transformer function preprocessor that will help. You just need to pass validate false. And if you're from the future, then maybe the situation will be better. There's an open issue to improve the doc. This is my personal website where the talk will be posted later, and JDA Labs is hiring also. Thank you.